Okay, going back to log again. All right, so first one we're going to look at is log base 7 of 3x plus 1 equals log base 7 of 2. All right, let's start with that one. All right, so most of you guys are getting this. I'm hoping you guys are getting this at home too. Remember that we have two logs, right? So we can just cancel those. As long as you have a log on each side, we're good. Then we can just set both of our a values equal to each other, and then just solve that. All right? Now, that's if we have a log on both sides. Well, what if we don't? What if there's only one log? Now what? What you gonna do? What you gonna do when there's no log for you? Math boys, math good, huh? Change the form. So this is in log form. What form are we gonna change to? Exponential. So the b to the e would be what over here? 7 what? Squared equals? Solve it. Don't be stuck on that 2. It's just 7 squared. So log base 5 of x plus log base 5 of 5 equals log base 5 of 8. Combine and then cancel. Yep. But now this time, there is a 2. So before you combine, you must get rid of the 2. To do that, that complicates things. So remember, when you guys have this number in front, I can bring it to the a value, and it becomes the exponent. So now it's the x squared, not 2. You don't multiply it or add it, and that's x squared. And now it's pretty much the same thing like the last one. Now you combine, and then cancel. Now you guys should be able to finish the rest. Remember, you got x squared now, so that changes your answer just a little bit. Or you're going to have to do one more step. So you get some point, you're going to combine those two, and then you get to this, right? 5x squared equals 80. All right. In order to square root that side, what do I need to have? All right, you want to isolate x squared by itself before you square root. Just like the last problem, you had that step, you knew exactly what to do. You divide by 5. It's the same thing. But before you square root, do that step and then take the square root. Okay? Because you can't take the square root of 5. It's a non-perfect square. It'll give you some kind of decimal and mess you up. Okay? All right. And then don't forget, square root, you get 2 solutions, plus and minus. So when you write your answer out, make sure you write it out there. This example, don't need to do this one. If I have a log of 2x equals 2, what do I do? Change the form. But what's my b? 10. It's automatically 10. So remember, if it's not written, that is automatically 10. So now I can change the form and solve it. All right, 10 squared 100 divided by 2. What if now, same problem, I'm just going to go ahead and write the 10 in this time. But what if it's minus 2? Okay, we'll just do the same thing, right? 10 to the negative 2 this time equals 2x. What do you guys think we do there? Okay, I like what you said because we did that in the last class. Well, let's just do this. It'll cancel it out. But the problem is, when you multiply the -2, what are you multiplying times? The 10, not the exponent. You got to deal with the exponent first. Think about that PEMDAS. All right. Actually, when you actually solve an equation, you're doing the PEMDAS backwards, by the way. If you think about it. Right? I'm not going to explain that, but yes. All right, because here we divide and then exponent, right? Square root. All right, so anyways, we got to change this number up. Make it a fraction. And with the deal with negative exponents is that if I move them between the denominator and the numerator, in other words, move it down, it now becomes positive. So if I move this down here, by the way, if I move that down there, what's left up here? 1, right? There's always a 1. If you ain't got nothing left, there's always a 1. So now this becomes 10 squared. Okay. So the same thing, let's say that it was on the bottom. Well, I can move it now to the numerator, and now it's positive. Okay, so just moving it between the numerator or the top and the bottom will change the sign. Okay, now 1 over 10 squared, which is a 100. But we're still stuck here. What do I do to solve that? Cross multiply. So what do I got to do with this one? Whatever 1. Cross multiply. 1 equals 200. Divide by 200. 1 over 200. Okay. So when you had a negative up here, moral of the story is you're going to have to take the reciprocal basically. Well, I guess it's not necessarily reciprocal because you are changing the sign, but you just got to flip it. Okay, and change the sign. All right. Now, when I combine these, you guys don't have to write on your whiteboard. This is just an example for you guys to look at. If you want to write notes, take a picture, no. Okay, so when I combine these, how do I combine these differently since it's negative? Divide, right? So now log base 12 of what over what? 3x over x cubed. All right, I'm going to deal with that in a second. But first, let's change the form. Okay, so we're going to do 12 to the -1. Okay, and then we have 3x over x cubed. All right, now before we do cross multiply and all that, what can I do over here? Think about when I have x up here and I've got the next term below. What can I do? Cancel what? Okay, so I got an x here, that will cancel, but I've got 3 here, right? 1, 2, 3, which means how many will cancel here? Only 1. Okay, so let's deal with that first. So now it's 3 over what? X squared. All right, let's switch this around now. This will be just 1 over 12. Now what's next? Cross multiply. X squared equals 36. Last step, square root. X equals plus and minus 6. Okay, if you want to take a picture of that, I would. It's a lot like the very last problem in today's assignment. Okay. But again, the common mistake I see with these ones when you don't have a log over here, if you guys are canceling, okay, don't cancel unless you have a log on the other side. You got to change the form around. Okay. Yeah, but when we divide, if you have similar variables, remember cancel those out. Okay. And it's always 1 for 1. So if I had x squared on top, I would cancel 2 on the top and the bottom, and then have just x. Make sure you're canceling only 1 for 1. Okay. All right, I'm going to go to the back. All right, so we got this unit circle you guys have been looking at last couple days. And it's a circle because it's round. You start here and you go around, and that's how many degrees? 360. If I go around again, it's another 360. Does that get any different? at some point? No, I just keep going around and around and around and around. There's a song back in middle school that we used to listen to. Around the world, around the world. Does it sound familiar, you guys? How do you know that?
Because I'm cool like them.
Daft Punk. Oh my gosh. That literally was the only lyric the entire song. We played for like 10 minutes. Middle school dance. All right. Anyways, so this thing, you know, you've got this circle. If you start here, you're at 360, you're at 0, you go around 360. It keeps repeating, right? Okay, a lot of things in life repeat. There's one thing that you really depend on that needs to repeat very smoothly and consistently. And it goes like this. What's that? That's a heartbeat. Boom, 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 boom. And what is it? Ventricles open up, atrium closes, boom, pushes the blood through. Ventricle opens up, closes, atrium closes, pushes the blood through. I don't know the exact science because I forget, it's been a while, but you need those things to work consistently, right? And they work on a wave, okay? Does anybody know what this is called, by the way, when you get this measured at the doctor's office? Anybody had this done before? They hook up all the little electrodes on your body. An EKG, electrocardiogram. Sometimes they call it an ECG, depending on what they're looking for. All right, I've had a few of those done when I was young. All right, so your phones, they work on radio waves. You ever watch the movies and they're looking at like their little screen, they're like, oh my gosh, the radio waves are getting intense, okay? That's called a sinusoidal wave or a sine wave, okay? A sine wave is based on the function sine, something that oscillates, something that keeps repeating itself. Here's what a sine wave looks like, all right? So what I'm gonna do is this is gonna be our y-axis. This is gonna be the x-axis. This will be 1, this will be 2, -1 and -2. Sorry, you guys can't see that. Let me zoom out a little more. That'll work. Okay, so 1 and 2. Now, remember it keeps repeating, right? Just like the circle repeats. 0, 90, 180, 270, and then we come back to 360 again. All right, so on the graph, when you graph these sine functions, we start at 0, just like the circle. The next mark on your graph will be the 90. Then 180, then 270. Notice we're going every 90 degrees, and then 360. Now, if I was to put that in radians, we start at 0. What's 90 in radians? Half pi, and then pi, then 3 halves, because remember this is 1 half, 2 halves, 3 halves, and then we end up at 2 pi, okay? All right, so if I start at 0, and just a reminder with sine, we talked about this yesterday, when I'm looking at the unit circle and I say, hey, find the sine of an angle, when you look at the value here, which part do you look at, the x or the y for sine? The y. And actually, I realize I have this written down wrong in my own notes. Actually, let me pull out the notes from yesterday because I have it all written down. There we go. So whatever is x, that's cosine. Whatever is y, that's what we're paying attention to right now. We're just looking at y, that's your sine, right? So if I'm starting here, the sine right there on the circle is what value? Let's go back to the unit circle. What's the value right there for sine? 0. So it starts at 0. All right, so that means that my graph starts in the middle. All right, then when I get to 90 degrees, right up there, what's sine? 1. So at 90 degrees,
It's at 1. What do you guys think it is when you get to 180? What? Huh? 0. It goes back to 0 again. Okay, now 270 down here, what sign? -1. Now it goes down. So on my graph at 270, I'm going to go down to -1. And then when I get back to 360, it goes back to what? It goes back to 0 again. So now it creates this curve. And when you actually graph every point in between, it creates a nice smooth curve. And after 360, it repeats this exact same thing. It just keeps going like this. And it will do that going to the left as well. Okay? So it creates a wave. All right, as you go from 0 to 360 or from 0 to 2 pi, depending on what you're using, radians or degrees, okay? Now we can change this. Now the graph of this is y equals sine of theta, sine of theta, okay? So that's what that graph is, it's sine of theta. Where I start changing it is if I add something or multiply something. So let's take that same graph. Color. And let's add, we'll just add 1. We'll do sine of theta plus 1. What happens to the graph if I add 1? Huh? Yeah, the whole thing just shifts. So there's like this midline here, right? That goes down the center of the graph. That shifts up 1. Okay? So that means that I'm going to start now at 1, and at 90, what's my first point? 2, because I'll just shift that up. And then at 180, where am I at? At 1, I come back to the line, just like I did here. At 270, I'm at what? Back down to here, right? 1 below that little axis I just created. And then when I get back to 360, come back to the line. So all that happened was I did this. I shifted up. So you can imagine if I did plus 2, then I would just go up 1 more, right? Plus 3, go up another 1. Minus, just go the other direction, right? Just shift the whole thing. Now, if I multiply, what if I did y equals 3? No, let's do 2. Not enough room for 3. 2 times the sine of that function. Well, did I shift it up? No, because I didn't add anything or subtract anything. I didn't create any shift. All I did was change how skinny it is. I stretched it. I did like the stretch where I did like a vertical kind of stretch. All right, we call that the amplitude. Okay, so it's still going to have a midline in the middle, right here. It's still going to start at 0, but when I get to 90, where do you think it's going to go? It's going to go up to 2. Now it's going to go all the way up here. And then when I get to 180, where do you think I'm going? Still in the middle. Still comes back to the middle. What about 270? Now what? I go down to, right. So now I'm going back down to here. And then when I get to 360, come back here. So if you think about it, it's like I'm taking all those values and multiplying them times 2. Well, 0 times 2 is just 0. 1 times 2 is 2. 0 times 2 is 0 again. But -1 times 0 is negative 1 times 2 is -2. All right, so now all that basically happens is as I stretch this thing, now it looks like that. All right, and that distance between the middle from here up to the peak or down to the valley, the bottom, that's called your amplitude. All right, this distance right here. So the amplitude of the very first ones, what's the amplitude of this one, the blue one? What's the distance between the middle and the 1? And then what's the amplitude of this new one? 2. So that amplitude, you can just look at the function and it's right here. It's that number in front. So there's a 1, right? There's also a 1 right there. All right, so let's take a look at how that works on our homework assignment here. So this one here. All right, so let's look at number 3. So we'll do a couple on here. So number 3, first, let's write out some things here. It says graph it, but let's write out the amplitude and the vertical shift first. It also asks you to do a dash line where that vertical shift is, and do a dash line where the period is. And we'll talk about period here in a second. All right, so first, amplitude. How much are we stretching it by? What do you think? 4. And what's the vertical shift? I'm going to put VS for vertical shift. 2. We're going to go up 2. Actually, here we'll just write out exactly what it is. We're going to say up 2. Okay. So what do you guys think the first thing I should do is? What? Okay, I am going to start at 0, but not right here in the middle this time. Where am I starting? At 2. So what I'm going to do is let's draw that vertical shift line, or the vertical, kind of like the midline, I guess you could call it. All right. So you mean of the function?
Yeah, you know when you like graph a regular function, like you find your y, that's at the beginning point. Usually you're seeing
Kind of. You could kind of, yes. It's kind of like that. So yeah, it's where you start. Okay. So now I'm still going to start here. And my next point's at 90, but where am I going? Up 4 from the midline, not from the x-axis, but from the midline. So the amplitude's 4, so I'm going to go up 1, 2, 3, 4. There's my first next point. Then at 180, where do I graph that point? Yeah, right there on the axis, right there on the vertical shift axis. Remember, basically we moved the axis, right? Now the next point is 270. Where are we going there? Right, down 4 here from here. So 1, 2, 3, 4. And then at 360, we're back at the line again. Okay, so now when you draw this out, just try to make as smooth a curve as you can as you go through here. Doesn't have to be perfect. But remember that the sine of this function doesn't stop, right? It keeps going. Now, before we keep going, this is one complete turn of the circle, or one complete oscillation, or what we call a period, a full period. Okay, so what it's asking you to do is draw a dashed line where that period ends. Okay, and then it repeats itself. Every 90 degrees, these points repeat themselves, right? So now the next 90 degrees, which is 450, is just like the 90-degree one, right? Up here. The 540 is just like the 180. So it goes right here. So it just keeps going. And I'll stop right there at the edge of the graph. Okay. Now let's do the one right above that, at number 2. Number 2, where's the vertical shift line? Where do we start it? At where? No. Right, down 1. Okay, we go down 1, and then what's the amplitude? 1/2. All right. So first I'm going to graph that middle line. Then we'll start same place. We'll start right on the axis, right on the y-axis, wherever that vertical shift and the y-axis line up. At 90, how far up am I going to go? Yeah, I'm going to go up 1/2. So don't go back up to x, because 1/2 is right there. It's in the middle. I'm going 1/2 unit. And then I go to 180, I'm back on the line again. Basically, if you think about it, every time I get back to 360 or 180, I'm back at 0 again. So I'm back to the middle, all right? Whereas at 90 and 270, that's when I'm going to be either up or down on this graph. So back at 270, I'm below. And remember, you're going only a half unit because the amplitude is 1/2. And then 360, I'm back at 0. 450 is just like 90, so I'm up a half unit. And then 540 is just like 180, I'm back to the middle, or back at 0. So now it's going to be really squished, right? So I got this really kind of almost flat, curvy wave here. Where does the period end? Where does it start over? At 360, right? So I kind of just emphasize that with the dashed line. I'm using a highlighter if you want. No. And there's something additional that we'd have to change with the equation in order to change that period. Right now, we're not dealing with that. It's when you start messing with theta or messing with this, like multiplying something, adding something, that's when it changes. But right now, as long as we're not messing with that theta, that angle part of it, it's going to be 360. Or if it's in radians, it would be 2 pi. Mm-hmm. It could, but we're not going there. Okay. Okay, we're doing everything based off kind of the foundation here, which is 360. All right, now the ones on the bottom here, they're in radians, but it's literally the exact same thing, right? Half pi is 90, 1 pi is 180, 3 halves is 270, blah, 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 so on, okay? All right, now back page. Okay, in the back page, these last 4, you're given the graph, so you have to come up with the equation. So with the equation, the template is this. Y equals your, what is that number in front? What do you think it's called? It's your amplitude, right? So it's the A, amplitude, times the sine of theta, plus the what? If I had to give that number a name. What are we adding or subtracting? The shift, your vertical shift, right? Now there are other templates of this equation. There's like A, B, C, and D, but I'm not doing that. I'm just kind of keeping it basic right now. Normally we call that the D value, but right now I'm just going to call it the vertical shift, okay? Right, so amplitude for this one, what is it? First of all, make sure you guys look at the midline. Careful now, look at the middle of the graph first. Notice the middle is right here. Right, so it's 1. You got to find the midline of your graph first and then figure out what the amplitude is. How far away is the middle to one of the peaks or to one of the valleys? So it's 1. And then what's the vertical shift here? Right, plus 1. Because it's how far away is the middle from the x-axis. And is it up or is it down? Okay, so now y equals your A, which is just 1, right? So I'm just going to put sine because I don't need to write 1. And then plus 1. So it's important, always kind of establish where is that midline of your function first, and then everything kind of goes from there. So it's basically starting with your vertical shift first, and then you guys go from there, okay?